And I've been working as an engineer for 29 years now, and the last few years I've become to ask myself this question more and more, and I believe that it's crucial to have a founded understanding of why we do what we do, because that determines how we work and how we approach our assignments, and ultimately how well we deliver to the users. I'll start with the understatement of the day, actually. Software is getting ever more important in our societies, with emphasis on societies, really. Everyone can see that. And one example of what ordinary people can see is that this was the bank of yesterday, and this is the bank of today. We do our own banking. It's a one example of how the society gets ever more computerized and dependent on software. Now, are we good at doing software development? Well, yes, in a sense, of course we are. We develop all the time new methodologies and more reliable software, better performance. It develops, definitely. But I mean, are we good at delivering software projects? Now that's a different question, really. I think we all know that we have some issues there. And I usually refer to research done by the Standish Group. Some of you may have seen this before, but I think it's very relevant. They started in '94, reporting annually, the Chaos Report, on the performance on IT application development in the United States. It's big enough to study. 175,000 projects per year. And '94, the performance was like this. 31% of the projects were canceled. Over half of them completed and delivered, but with huge cost overruns. 16% delivered on time to budget. Now, is that good? Of course not. Not even close. How it's been developing since then? I have a few numbers, a series of few years here. We can see that we have actually been picked up and delivered better now. 16 has doubled to 32% of our software projects deliver on time to budget. But it's almost still half of them, 44%, that suffer severe cost overruns and delays. And 1/4 are canceled. Is that good?
That's still in the US, right?
Still in the US. Still a relevant comparison.
It's interesting to have the other view of things, what happens.
The Standish Group concentrates on the US performance. I think, what Standish Group also said right out from the beginning is that they could see patterns like small projects perform better than big ones. And shorter increments is more successful than longer increments. Doesn't sound like rocket science, but we have, during this period, we have agile methods that are being developed, and hopefully, and perhaps, they have impacted on the better performance, that we actually try to run smaller projects and more importantly, shorter increments. That gives us the opportunity to navigate more often for changes in the environment. Of the challenge projects, those that actually are completed but to cost overruns, it's interesting to take a look at what the challenges are. And this is a list of the main challenges, and I'll stick with the top 3. Lack of user input, incomplete requirements and specifications, and changing requirements and specifications. And I'll stop there because you can see that these 3 are probably related. Because if you don't have enough user inputs, requirements and specs will be incomplete and will be changed later on when people realize they need to fill the gaps. So, what does that tell me? That's what we should focus on to get performance better in our software projects, to get better user coordination. But the problem is, when you specify new products, who can fully specify a product that don't exist? I know I can't, I've tried. And I think it's an inherent problem in development of new products. You cannot fully specify them. It's partly an investigation. The project is partly an investigation. You'll discover things that affect the project as you go. But we need to involve the user more. And most of the user requirements are actually based on how they experience the new product. And they will know that when the product is delivered. So how do you, and it's more of a feeling of how they experience the product. Is it easy enough to use? You could say, specify it should be easy to use, but it doesn't help anybody to design the system. So it becomes unspecifiable, doesn't it? And who are we building for, really? Who are we building systems and products for? The customer? The user? I know that in military projects, the customer is never the user. And that's a challenge. So it's a challenge to specify everything, because it cannot be done. I heard a guy from Walt Disney Studios a couple of years ago present something of these challenges from theme park development. You know, Disney World, Epicenter, Universal Studios, and rides and experiences. And you have to design and you have to specify those theme parks because it's technical stuff. And they gave us one example, an example of a silly question from theme park development. And this is it. This is a ride now. The truck veers off the road, bounces down the side of the hill, ends up in the gully, then drives off down an old riverbed. The path down the hill looks like it's never been driven on, and the riverbed looks like a real dry riverbed full of big rocks. Can you make the ride smooth? Not too jerky, but bouncy. Now build it. Well, this I don't think this is a silly question. It's a feeble attempt to approach this the engineering way. You cannot specify in technical terms that are verifiable in tests what the user really wants to have. It's an experience-based test or decision if it's good, if you have delivered good. As Göran mentioned, I have spent many years on trying to use model-based systems engineering. We started out at Saab beginning of the 90s with testing new ways of formal specification. And I firmly believe still that what we can specify should be modeled and specified like this to get rid of ambiguity, incompleteness, and misunderstandings. And we should do this. And these methods are developing and getting even better. But what they never will help us with is understand what the user needs. That comes before we model. The user again. Is the user a nuisance? How do we see the user? How do we value the user? Is it like this? Can you read it? I met this attitude, and it doesn't help us, of course. And I also know that some users look at us the same way. We're idiots. We don't know what they need. Now, if society gets even more computerized, and we build very complex systems and solutions for different parts of society, most people are not as good at doing software and understanding software and computers as we are. And that is basically most of the people in the world. Many of them are going to use our products. And I think that the user should not be faceless. We should actually confront the user a little more than we actually do. Now, I'm going to give you 3 examples of different ways of involving the user in product development, of good and maybe not so good approaches. I'll start out with the one I know best, the Gripen fighter program that Saab has been running now for quite some time, and I spent 12 years in this program with that fighter. But I'll focus just briefly on the cockpit environment, because that is a good example of user-centric design. Pilot now is the user, and that cockpit has actually been designed around the pilot. What you see here is the 3 multi-role screens, the stick, and the throttle.
This might excuse me a question. Here you mentioned that the pilot is the user, right?
Yes,
Who buys this plane?
not the pilot.
So how do you sell this plane? I mean, the effort that you make on the pilot, does it actually help you sell the plane?
Oh yeah, definitely.
So they have a stake in the decision process, saying yes.
They're part of the development process on how this is designed. And that's my point here.
But are they part of the buying process?
Yes, they are that too. They're part of the selling process, I'd say. They participate in the selling effort that Saab will do, of course, because they can tell other pilots in other air forces how this works and how well it is designed. Maybe this is not the ultimate product in all aspects, but what I want to focus on today is the user, the pilot environment. The pilot flies this HOTAS, hands on throttle and stick, when in the air. But on the ground, the right hand is free, and therefore all the, you can't see it here, it's below the picture, all controls and buttons and knobs that are to be used while on ground, taxiing, they're on the right side. That's one way of approaching, make it easy for the pilot, because the whole mission here has been to decrease the information pressure on the pilot, information load. If we take a look at some parts inside this cockpit environment and see some panels, for example, it's designed with a uniform user interface in mind. No matter what system, no matter what function we're talking about in the airplane, you have design principles that they all need to comply with. Meaning that when the pilot sits here, out and forward on knobs and controls and levers means on, always on. Clockwise always means increase. Can have a system that turns the other way, would mess up the situation for the user. And they use also tactile feedback. I mean, you have round knobs, so you can have knobs with edges, and you don't need to look at the panel. You feel which one you're touching and controlling. And on the screens, the multi-function screens, they're configurable. They can change it between them. You have keys around them. And it's always, no matter what information you have up on the screen, return to main menu is always on the same place. And otherwise, other industries have figured that out too, like the iPhone, one button here back to the top level. And it's a very shallow menu system, maximum 2 button clicks, and you're down at the relevant information. There are no more levels. And you have a standard for abbreviations. Doesn't matter who delivered the subsystem and how it's going to be presented in a uniform way to take the load off the pilot in interpreting the information. And the recent years they have put a lot of effort in taking the load off in terms of alarms, because you have a lot of potential alarms in a product like this with dozens of onboard systems that could malfunction or operate just a little off normal operating point and would like to alarm to the pilot. And this one first. Everything has been designed with the principle inside out. Everything has been designed to be shown from a pilot perspective. Doesn't matter if it's on the head-up screen, multifunction displays, it's always with the pilot in center. The information is presented in that fashion. And that conforms with the mindset of the user. Now, this is the alarm philosophy. It's a dark panel philosophy. Here you can see the alarm panel. And if everything is black, everything is well. And they don't issue alarms for problems that don't require direct pilot action. You could have alarms that come during a flight, but if it has to do something to do about maintenance, it's never shown to the pilot. It's stored, and the ground support personnel can see it after the flight, and they are the receivers of that alarm. Every alarm is categorized with respect to level of threat and criticality and presented accordingly. And one top event could trigger a cascade of sub-events. So you need to have the relations between the alarms. You only want to present the top event, and again, if that is critical and requires action. Otherwise, forget it. And it's always presented in a uniform way. Alarm overview, detailed information, and action plan. Just this environment, the cockpit environment for the pilot, is one example of very successful user-centric design, because it's become very easy to fly this airplane. It takes less than 10% of the pilot attention to fly the airplane. And remember, the pilot is not up in the air to fly. The pilot has other missions to do, like intercepting another fighter, attack, reconnaissance mission, or all three. So the least attention paid to the flying the airplane. It's just for taking the airplane and the pilot from A to B, really. And I know it's easy. I haven't flown the airplane, that's fortunately, but the simulator is quite close to the performance of the airplane. And actually, the first time, you can take off, fly a simple mission, and land successfully. I've done that without crashing, really. So it's very easy to fly the airplane. And now Saab has hired pilots, and they take part in the development and how you design the cockpit environment. And that's not unique for Saab. I believe all aircraft manufacturers do that. But that is one good example of user-centric design. And the software developers don't know what the pilot knows and what the pilot requires and what the pilot job is all about. And vice versa. The pilot doesn't know what the software developers can do. So it's different knowledge systems that need to meet. The second example is a comparison between two products. Here we have a fully automatic grenade launcher, 40mm grenades, and this particular example is equipped with a lightweight video system, it's called. I don't know what is lightweight, but it's on the right side here. And you have a ballistic computer, battery pack, laser rangefinder, night vision capabilities, and all kinds of stuff. And you have a screen mounted on top on the gun. And it gives you a 3-inch magnification, and the soldier actually shoots through, sighting through the screen. Now, as you can see a little at the bottom of the screen, there's information presented at the bottom. Also on the left, what you can't see is that on the top you have scroll down menus. And you have buttons here and a 4-way joystick. So imagine you shoot at an enemy tank and you miss, but now you're detected. Maybe you had the wrong parameters set in the computer for that kind of ammunition. You need to go in. You have to fiddle around real quick with the joystick now to bring down the right scroll down menus and pick new ammunition, ballistics information. And in the corner of your eye you can see the turret turning the gun against you. And you have 1, maybe 2 seconds more to live. Okay? Quite a stressful situation. I've seen another site. I'll focus on the site now. And this is a site, this is a red dot site, you can hardly see it here. This is the site view, but I want to show the information in the site that the user sees. The sites, at a building there, you have a threat there, and in this site there are no scroll down menus, no joysticks. You have already your fingers on a couple of buttons. One is the rangefinder. You get the range, and you also get an automatic correction for the chosen ammunition you have. So you need, it's compensated for distance and other things. So you need to adjust, just lift the gun, and this is, by the way, made for the anti-tank weapon called Gustav, rocket launcher. And you fire, and that's about it. Now, that was a little simpler. And I know that Aimpoint, the Swedish manufacturer of this site, has brought in the users in actually defining what information should be shown in the site when I use it. And it's meager, but it's enough. It's what you need to know. And if you need to change the ammunition type, if you have the same mistake here, it's a toggle function on the next button. And you see it on the screen, and you stop when you write, and you shoot again. Then I have a quite different example from a totally different business. This is where you might end up if you have encountered the previous weapons. But this is a trauma room. I know a few nurses. I've heard terrible stories of how they receive new equipment for the trauma room. And was kind of annoying to hear that engineers build stuff that don't work that well. And one of the nurses were actually quite close to me, I mean, really close to me, told me a story, many of these stories. And I said once, write it down, please. And she did. And so I got a story, how their first encounter with their new blood warming system. And I'll share this story with you. It's a one-page story. And this is the equipment, the new equipment she's describing here. A blood warmer is an electrically powered device that heats fluid to be infused into a patient. It's often equipped with some form of pressurization to increase the speed of infusion. For example, when massive bleeding occurs during surgery. One day we got a new blood warming system to our surgery clinic. It was said to be far better than our old bulky equipment. Apart from the power cord, the old system was equipped with 2 blood pressure cuffs. Both were connected to compressed air supply. That is 2 air supply tubes and 2 power cords. And that is a lot of tubes and cords in an already high-tech environment. The new blood warmer had only 1 power cord to be connected into the power plug, and the blood pressure cuffs were electrically powered. That's great, we said. The old blood warmer was swiftly sent to Estonia. And here's the new blood warmer. The heating unit, the blood bags, and the compressor. One late night, there was a traffic accident and we received a trauma alarm. The patient arrived in a very serious condition and we decided to use a new blood warming system, since it turned out to be necessary to infuse the patient with large quantities of blood. Said and done, we mounted the new wonderful piece of equipment, pushed the button, and nothing happened. The thing was dead. All lamps were green as expected, but there was no pressurization, so the blood just dripped slowly, while the patient's blood pressure dropped drastically. Disaster. So we quickly ripped down the blood bags, and using hand power, we pressed the blood into the patient. And I can assure you that this is a very tiresome and ineffective way of keeping the patient alive. After the operation, we were quite upset and we contacted the sales representative that has sold us a new blood warmer and asked what went wrong. He explained that there is a separate power switch for the compressor and it's placed under the device at floor level. Absolutely impossible to see if you didn't already know it was there. Why on earth is it placed under the device, we asked? Well, because it cannot be exposed to fluid. And if it would be placed on a visible surface, it would be drenched in blood during a trauma case. So why don't you put a switch that can be exposed to fluid there, we wondered. And by the way, wouldn't that be appropriate for a device to be used under very wet conditions? Altogether, wouldn't it be nice to have a nice thing to put such an important switch in a fully visible position? After all, it may be a question of life and death. We'll forward your viewpoints to the manufacturer, the sales representative said. And there it actually ended. Why don't they ask us about the environment equipment is to be used in and what we need before they build the stuff? Now we have put a big red note on the blood warmer where it reads, "Don't forget the compressor switch, it's under the equipment." Later, after this incident, we used the blood warmer again, when suddenly we had a blackout in the surgery room. All fuses blew, and when we changed them for new ones, they blew too. After a certain amount of panic and quite some time to locate the problem, where we systematically shut down all the surgery room equipment one at a time, we found that the new blood warmer was to blame. We later learned that this piece of equipment was so packed with advanced electronics that it needed to have a power plug on its own. Unfortunately, our surgery rooms don't have so many power plugs that this is possible. One quietly wonders if the medtech engineers have ever set foot in a hospital and seen the grim reality with budget cuts and postponed refurbishments. We need stuff that works, not technical miracles. P.S. The patient under surgery survived. If that had not been the case, who would have been held responsible? I promise you that this would have been the anesthetics nurse on duty, not the engineer. The nurse would probably have been accused of being irresponsible for using inadequate equipment. That's the story of the anesthetics nurse. And I can't help wonder if the systems architect of that piece of equipment just forgot or didn't care or considered didn't need to know under what conditions this equipment was to be used. And I wonder how many products have we built that I've been part in where the user have had a bad surprise with our products. Do I even know? Do I want to know? What we can see in these cases actually is sometimes a clash, but it's a meet between different knowledge systems. Every profession has its knowledge system. We have ours. And I've been working the last, say, 10 years with research on what knowledge really is and how we can learn in new ways and see our knowledge. What is knowledge? That's a fairly simple question, isn't it? But I can tell you there is no one simple answer. There is not one single model that explains what people know, what humans can know, and what knowledge is. The ancient Greek philosophers asked this question. Most of the dialogues you have in Plato circles around this. What can we know for sure? And we still ask ourselves that question. But we've been working with a lot of knowledge models, and I'll show you just one that I think is expands our understanding of what human knowledge is all about. And it's taken from a Norwegian philosopher called Kjell Johannesson at the University of Bergen. It's based on Aristotle. That's an invention. Propositional knowledge, skill, and knowledge of familiarity. There are not three different kinds of knowledge because what we know is intertwined. But it's three different aspects of what people can know. First of all, propositional knowledge is also called formal knowledge, or things you can write down. Like mathematics, graphs, everything that can be written down and can be given in courses, lectures. In industry, we write a lot of manuals and handbooks. That's kind of propositional knowledge. You can hand it over to somebody else, and they can learn, and you can test them. You can actually measure that kind of knowledge. That's just about the only knowledge a human has that you can measure. You can give them a test and count the number of right answers. Simple. Unfortunately, that's not the kind of knowledge that makes a good professional. It's not. What we value with good people is skill. I was challenged when I started this. Well, experience, that's not knowledge, is it? But I can't measure it. I can't even express, how do you express experience? You don't, but you have it. And I had finally to acknowledge that, well, skill can actually be seen as an expansion of what you know, because this is something you do. It's practice. You acquire skill by doing it over and over again. If you, for example, want to be a project manager, you can take courses on which are propositional knowledge. You're given a project model. This is how we run and operate projects, and we have these gates, and you can learn how to estimate, to make time plans and risk analysis, and those are the tools of the project manager. Now, when you've taken those courses, you are still not a project manager. But maybe after you have run one project, and the second, and seen that they were not alike, and the third, and new things appeared, you have learned something more that you couldn't be taught during the course. And that is also valuable because it builds professional judgment. And after a long time in your profession, you build knowledge of familiarity, or the feeling for the job. You learn to see the subtle signals that others don't see, and you take action on them. Intuition. gut feeling is very close here. For example, an experienced project manager during a project meeting hears what a person says and thinks, why did he express it that way? Why didn't she mention anything about that? I've been here before, something is not right. And takes action based on that. Then you have some knowledge of familiarity. And how do you state what you know? You don't.
The distinction that you make between skill and knowledge of familiarity is a bit
Fuzzy, I know.
Yeah, their two are very intertwined.
Yeah, definitely. It's a matter of levels. You may, I mean, after long practice, you develop, let me call it hearing or seeing.
Yeah, intuition.
Yeah. But after
So
you
it's the ability to extrapolate from your practical knowledge. That's what you call knowledge.
without knowing how.
Without explaining it in a rational fashion.
Yes. So I'm not saying it's there are no sharp boundaries between these perspectives.
There is an interesting example that was given on a famous art case. The foundation estates bought a statue, a Greek statue, and they paid millions of dollars. And they asked after the fact an video art expert, is this they confirmed that this is a real statue. They said, I cannot tell you why this is a fake. And it took them several years and analysis to confirm that it wasn't fake.
So what did he know that made him so sure that it was a fake?
That it comes from knowledge of familiarity. He couldn't explain it.
No. Because it's tacit knowledge. And we have, yes?
So the first is the what, so the second is the how, and the third is the why.
That's what Aristotle said. Yeah. So what have we learned for 2,500 years of knowledge? But the thing is that this is pretty much the way it is. We all are professionals. We carry these kinds of knowledge systems within us. And it cannot be expressed explicitly, handed over to somebody else before somebody retires. You cannot write down everything he or she knows and hand it over to the new person that takes over. It's not possible. But that's the way it is. I show you this because we have our knowledge system, and those we build systems for have their knowledge systems, and they're different. And by the way, I have a colleague that argues that we really don't have a practically useful theory of what software development is all about. There is no such thing, and I was stunned to hear that, but after giving it some thought, I'm inclined to think he's right. We don't fully ourselves understand what software development is all about. It's partly here. Maybe it will be there for big chunks of the profession will be there, of course. Now, every profession has its tacit knowledge, has its propositional knowledge. The nurse, the soldier, the pilot, and the engineer, totally different. But we build products for them. And whether it's a professional user of a military control system or an ordinary user of consumer electronics, it's the meet between the different knowledge systems. And we need to know under what conditions the user works and what the user knows and understands in order to build the right products for them. And one way to bridge this, because since it's tacit knowledge, cannot be specified. How do we do? We don't write it in the spec. What we have done recently is, with inspiration from the cockpit design, we started something called Reality Labs. And we build usable products for our customers. And we have started to use demonstrators more and more. Because if you show, you get a reaction. maybe then you can specify. I show you just one example of an airport docking system. And when an airplane comes into the terminal building to dock, there's now an equipment on piece of a screen on the wall on the building where a ground staff personnel actually helps the pilot with lasers and guide him into the right position before the airplane is docked. Now they wanted to have a mobile unit for the ground personnel to move around and be able to support the pilot docking the airplane. So we started to sketch, first in PowerPoint. We suggest that on a tablet, you see these functions on the top level, and the set gate, and you get the layout of the terminal building where you can see all the objects and airplanes and the status and so on. And I assure you that when you show something like this, that the engineer has tried to understand what the challenge of the user is and what functions need to be on top and how it should be displayed. When you show this, you will get a reaction if you show it to the user. And they say, that's not so important, not up here, and by the way, we don't usually use blue circles to symbolize this. Why? Well, we have this other system, and it would be good if it complied with that, and you get this dialogue between the engineer and the user over the things that the user didn't know was important to tell the engineer, wouldn't be in the spec, and the engineer didn't know to ask about. And we delivered, this is actually the layout that we delivered, still a demonstrator, not coupled to the real system, but you can fiddle around with it and get a feeling of how it would operate. And now they have to make a decision, do we build this product or not? So it's also called prototyping if you start early, pretendo prototyping. And you can do paper sketches, but the thing to show, modeling, really, it's modeling in the early phases. Modeling for the user. You bridge the gap to the unspecifiable requirements, somewhat at least. Now, as software engineers, we build products and systems for ourselves or for other people. What is it? We build for other people, right? Most of the times we actually build systems and products for other people. What does that mean? We serve other people. And I believe that we tend to forget that from time to time. Because that makes us obligated to find out something about the user's working conditions, the user level of understanding. We need to meet those knowledge systems just a little. And that is our responsibility. Because we deliver things, and I would like to be proud of what I'm part of being delivered. I'd like to be proud of what systems that we deliver, and I want to hear the users say that they love the products. Now that's a challenge. And I think that this is a mindset, really. It's a mindset. You need to see yourself as being a servant. That's harsh, but in essence it is. So I'll challenge you, still early morning, with a more or less a poem by the Danish philosopher Søren Kierkegaard. It was written a nice few lines on what it is really to help another person. It's a 19th century philosopher, and he wrote this, and I'll read it out loud for you. If one is truly to succeed in leading a person to a specific place, one must first and foremost take care to find him where he is and begin there. This is the secret on the entire art of helping. Anyone who cannot do this is himself under a delusion if he thinks he's able to help someone else. In order truly to help someone else, I must understand more than he, but certainly first and foremost understand what he understands. If I do not do that, then my greater understanding does not help him at all. If I nevertheless want to assert my greater understanding, then it is because I'm vain or proud. Then basically instead of benefiting him, I really want to be admired by him. But all true helping begins with a humbling. The helper must first humble himself under the person he wants to help and thereby understand that to help is not to dominate, but to serve. So, my last slide. I think this is something I challenge myself with from time to time. Do I really think like this? The times I do, it's a successful case, I know, I can tell you. So, get out there and meet the user every once in a while. It may not be in the budget for software developers to meet the user, so we might have to demand it. But if we know that even the software developer makes a lot of decisions that ultimately affects the end product, and if you know what the real demands is, if you know what the user wants and needs without being able to specify it, you're able to deliver it. Because most of it, what the user needs is not specified. So go, meet the user, build the right stuff, because that, my friends, is real systems engineering. Thank you for your attention.
Thank you. I think you have served as well this morning. I see a lot of nods and smiling faces, but I'm sure there are also some questions.
You draw a strong distinction between a pilot and a nurse. I've been involved in a few projects with pilots, and I've been amazed by the power that they have within a project. Usually the customer's pilot signs off on the design, and therefore you don't have to be the right sort of engineer to want to help the pilot. They have to help the pilot because the pilot has power. The nurse has no power in your scenario, isn't asked to sign off on the device. So I think we can look at not just altruistic ways of helping, but actually structural ways of ensuring the end user has a stake and is able to actually involve themselves in the acceptance of the technology.
Good point. And isn't that our responsibility to bring out the silent user that has no power and give them power? Say, we need to involve them in our development for us to be successful.
That's hard because if you take the nurse in a hospital, they're considered the lowest level of human species, and always the professor who makes the buying decision. And to revolutionize that, it's a hell of a job. And again, the persons that build these machines, what they want is to sell these machines.
Yeah.
First. That's the unfortunate reality.
Yes, I know. But still.
On the other hand, medical device industry, we have, luckily, we have organizations like the FDA in the US, which demand usability testing. For, I think, the last 2 years, they really forced it, especially in our area of infusion pumps. They said, hey, without doing this, and not only with 2 nurses or with 3, with 25, 30, 50 nurses, we're not allowed to bring your product to the market.
That's a good thing. In my whole career, I've met 3 companies that deliberately and planned sends software engineers to the end user environment to see how their products are used. 3 companies.
But you have another problem, especially with the nurses, because if you're working in Europe, you have a very well-trained personnel in the hospitals. If you're going, for example, to the US or to Asia, sure that anything working in Europe is working in any other market?
As the cell phone manufacturers, they have encountered the same problem where you have to make cell phones for illiterate persons as well-educated persons, and they're different products. No surprise.
The answer here is in some places you need regulators to step in.
Yeah, that would help, and I think we can actually make our contribution and request to meet the user with what kind of status they might ever have. Because we are responsible for delivering to them. And I think the case I've shown you is could be serious if you don't understand, if you don't listen and don't understand the real environment the product is going to be used in. You can take a look at the product and say, wow, it's good, it works. Because I know how to fiddle around with it. But I'm not the one using it under critical situations in the surgery room. I don't know what that means. I haven't been there. Awake at least.
Frank has another
Yeah, I
question.
have a question to the academic community. How many computer science departments mix courseware with a psychological department or cognitive science department? Today. Because that's what you're talking about.
I'll answer. I think many departments have HCI and other disciplines which have psychologists and people within them. I think there is an understanding that you do need to be multidisciplinary to teach aspects of design. So I think yes, I think there are. You will find many broader-based courses in computer science as well.
Is that a recent trend or is it like 10 years old?
I would say, it's, for what I know, it's a recent trend, at least in industry. The interest is growing on usability approaches and cognitive aspects of using a product. But for the academic part, I don't know.
For the industry, Frank said yesterday, Apple, bad or good, we don't know. It's a big effort for the industry because they show us one thing, to make a really simple, easy user interface. And that's something you often find, especially in hospitals. Hey, why is your user interface so complicated? Here we are.
Exactly. I've customers who have been confronted with the same thing. Their users, the professional users of their equipment, are also using simple smartphones and tablets and say, hey, why can't your product be that simple? So the pressure is increasing on industry that delivers today maybe far too complex systems that make them simple. Others can't. Why can't you? So there are coming new requirements, I bet. Yeah.
I'd just like to address a comment to the room, really, rather than to you, that many of the people in this room are involved in one specific product, a product called Ada. Is Ada a joy to use from the second you start a project to the second you put it down?
Yes, of course.
Okay, I'll try to use my tactic knowledge to see if there's anybody who's have a burning question here. Yeah. No. So, thank you very much.
Thank you.